Muy buenas tardes a todos y todas. En nombre de la Escuela de Ingeniería Oceánica de la Universidad de Valparaíso, les doy la más cordial bienvenida a esta conferencia que se enmarca en el curso internacional sobre uso y modelación de datos históricos y proyecciones futuras bajo escenarios de cambio climático, una instancia donde ciencia y soluciones aplicadas a las comunidades se enlazan. Nuestra escuela tiene la convicción de que la ciencia y la ingeniería deben ser actores clave en la respuesta a los desafíos globales y por ello promovemos no solo la generación de conocimiento de fronteras, sino también su transferencia efectiva a los territorios, especialmente aquellos expuestos a amenazas climáticas y oceanográficas. En este esfuerzo, la colaboración es un pilar fundamental. Por lo tanto, queremos destacar especialmente la articulación que ha hecho posible este curso gracias al compromiso de actores nacionales e internacionales. Queremos expresar nuestro profundo agradecimiento al proyecto de construcción de sociedades resilientes y sostenibles frente a desastres en América Latina y el Caribe, llamado KIZUNA II, que es parte del esfuerzo conjunto entre el Gobierno de Chile y el Gobierno de Japón a través de sus agencias de cooperación, la Agencia Chilena de Cooperación Internacional para el Desarrollo, AGCID, y la Agencia de Cooperación Internacional del Japón, JICA, con la colaboración estratégica del Servicio Nacional de Prevención y Respuesta ante Desastres, SENAPRED, que forma parte activa de este programa. Este entorno colaborativo es el que nos permite contar hoy con 18 estudiantes provenientes de Bolivia, Brasil, Costa Rica, Ecuador, Guatemala, Honduras, Panamá, Perú, República Dominicana y Uruguay, así como la participación de un invitado verdaderamente excepcional. El doctor Hiroki Kondo es físico de formación por la Universidad de Tokio y cuenta con una trayectoria de más de 50 años en investigación, formación y liderazgo institucional en temas de meteorología, oceanografía y cambio climático. Ha ocupado cargos directivos en la Japan Meteorological Agency, ha sido director del Departamento de Investigación Climática del Instituto de Investigación Meteorológica del Japón, el MRI, y asesor del Ministerio de Educación, Cultura, Deportes y Ciencia y Tecnología del Japón ante las sesiones de la UNFCCC, de la COP y el IPCC. Fue también jefe de la Oficina Nacional de Apoyo al IPCC, del Grupo de Trabajo 1 en Japón, y ha tenido un rol destacado como científico principal en el proyecto japonés para el quinto informe del IPCC, desempeñándose en instituciones como el JAMSTEC y RESTEC. Actualmente es asesor del Remote Sensing Technology Center of Japan, RESTEC que mencionaba recién, y es académico en la Universidad de la Ciudad de Yokohama, además de continuar colaborando activamente con JICA y el JMA en formación avanzada en cambio climático. En esta conferencia, el doctor Kondo compartirá con nosotros una perspectiva técnica y científica sobre la evolución del cambio climático global, con base en la evidencia consolidada por el IPCC y otras agencias internacionales. Abordará también los escenarios proyectados por los modelos climáticos más recientes y las implicancias que estos tienen para la planificación estratégica, la cooperación internacional y el futuro de las zonas costeras vulnerables. Para nosotros es un honor contar con su presencia y su experiencia. La conferencia, el doctor Kondo la hará en inglés. Por lo tanto, quienes lo necesiten pueden acceder a la traducción, a la interpretación al español, apretando el botón hay un mundo que aparece abajo que dice interpretación. Entonces, si apretan ese botón, van a cambiar al canal de audio donde están los intérpretes que van a estar, como decía recién, interpretando lo que va a decir el doctor Kondo. So, Kondo Sensei, please, now you can share your presentation, and you are very welcome, and we are grateful to have you here with us tonight. By the way,
Thank you.
para los que no sepan, en Japón hoy día es la mañana, así que allá son las 7 de la mañana. Doctor Kondo está acompañándonos en un horario completamente distinto. I was saying that for you it's the 7 in the morning, so we're very thankful for you to be here with us right now. Please.
Thank you. Here, the first slide shows the title of the talk lecture of today, analyzed and projected global warming and related international policy measures. Its contents are shown downside. So you can see English, the contents, introduction 1 to 6 and summary. So I'll talk in this order. Thank you. Okay. Then next slide shows the introduction, origin of the climate change issues and the IPCC. Okay. Here we are talking about the climate change, and the climate as a system consists of various subsystems: atmosphere, hydrosphere, cryosphere, biosphere, and so on. And all these subsystems are interacting each other. And also we have the outer forces like solar radiation, and also the human influences, volcanic activity, and so other outer forces. Then I'm just want to focus on a very important activity of these interactions, the greenhouse effect. As for greenhouse effect, the IPCC shows a very nice diagram shown in this slide. The greenhouse effect, in the greenhouse effect, some of the infrared radiated from the sun come to the earth and reflected by the atmosphere or by the earth. And almost half of the radiation was absorbed by the earth. But the earth is then warmed, and warmed earth emit earth radiation, which is also called the infrared radiation, is emitted from the Earth's surface, and then it almost absorbed by the greenhouse gases, and the greenhouse gas then emit to various directions, including to the earth, back to the earth. So the radiation back to the earth causes some warming back. And this is very important effect of the whole system, because without greenhouse effect, surface average temperature would be present 14th degree, but minus 19 degrees. Then there will be no living things like now. So this is the greenhouse effect is very important for the living life on Earth. However, the problem is we are losing the balance of greenhouse effect in the atmosphere. Composition of atmosphere shows in this program diagram, and as you may well know that the atmosphere, dry atmosphere, consists of nitrogen, hydrogen, argon, almost 99.93%, almost all one of these three elements. However, other very, very tiny part, 0.07%, include the greenhouse gases, as shown by red inks. Carbon dioxide, 0.0391%, or 391 ppm. Methane, nitrous oxide, from 11, ozone, and so on. These very, very tiny part of the atmosphere are now affecting the climate change. Now here this diagram show the changes of carbon dioxide since the first observation at the Mauna Loa, Hawaii, in 1950s, when there was the international observation activities called IGY, International Geophysical Year. And since then, as according to the observation, the concentration of carbon dioxide is getting greater, getting larger and larger. And until now, it never decreased. Of course, it includes various variations, year-to-year variations, because there are the forest or other carbon photosynthesis activities. Now, here is the scientific origin of climate change issues. What will happen if global scale concentration of carbon dioxide continues to get larger? That is the origin of the issue. Now, was this questions based upon model simulation study of the response of the climate to the increase of carbon dioxide concentration. Shukro Manabe from Japan and his colleagues at the GFDL, Geophysical Fluid Dynamics Laboratory in Princeton University, predicted global warming in the 1970s, 75. As you know, Nobel Prize in Physics in 2021 was awarded to him with two other scientists. So the IPCC corresponding to this results of climate change prediction international community are quite concerned about the future of the Earth, and then the IPCC was established as a United Nations body for assessing the science related to climate change, established in 1988 under the cooperation of WMO and the UNEP. UNEP means the United Nations Environment Program. So IPCC then started issuing assessment reports, special reports, and some other reports. This is the diagram of IPCC, Intergovernmental Panel on Climate Change, established in 1988. And the structure of IPCC is shown at the last stage of the sixth assessment report. Now, WMO, UNEP cooperate, and then IPCC here shown. IPCC include 3 working groups: working group 1, 2, 3. Working group 1 assesses the physical science basis. Working group 2 assesses on impacts, adaptation, and vulnerability of climate change. Working group 3 assesses mitigation of climate change. There is some other part which deals with the climate data. It's called Inventory Task Force. Now, as for the latest assessment report, sixth assessment report consists of these parts. Working 1 deals with the physical science basis. 2, impacts, adaptation, and vulnerability. 3, on mitigations. And each consists of various items like SPM, summary for policymakers. This is a very important part because this is a summary of the assessment report. And so it's very carefully approved line by line by the international meeting. And so as the policymaker rely on this report, especially on SPM. And the IPCC issued first report, first assessment report, which is sometimes abridged like FAR. In this report, the main message is as follows: continued accumulation of anthropogenic greenhouse gases in the atmosphere would lead to climate change, It's not so definite, okay? Because the study, the research has not been too much done. But at this stage, at least the scientists say that, and they assessed that the would lead to climate change. Second one issued in 1995, and then it said the balance of evidence suggests that there is a discernible human influence on global climate. A third one was issued in 2001. Most of the observed warming over the last 50 years is likely to have been due to the increase in the greenhouse concentration. Here is only is likely to. Likely in this report means probability of 66 to 90%. But even at this stage, policymakers started moving, and on the other hand, the Nobel Peace Prize 2007 was awarded jointly to Intergovernmental Panel on Climate Change, IPCC, and the person Albert Arnold Gore Jr., who is past ex-vice president of the United States, for their efforts to build up and disseminate greater knowledge about man-made climate change and to back to sorry. Let me.
Kondo Sensei, you need
Yes,
assistance?
I want to take back the just. Let me just take out. Oh, sorry. Okay, sorry. Come back to the slide again. The Nobel Peace Prize 2007 was awarded because the IPCC and Mr. Gore for their efforts to build up and disseminate greater knowledge about man-made climate change and to lay the foundations for the measures that are needed to counteract such change. And so the role of IPCC has become further important for the mankind through these activities. I don't go into the details, but and so because the policymakers around the world moved on, and after the publication of the IPCC first assessment report in December 1990, the United Nations established the negotiating committee to form the body. It is called UNFCCC, United Nations Framework Convention on Climate Change. At the UN adopted the UNFCCCs with it's very important article too on objective. It says the ultimate objective, blah, 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 is to achieve, blah, 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 stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic man-made interference with the climate system. And actually, in March 1994, UNFCCC entered into force. But at that time, especially at the start of the year of 1990, carbon dioxide emission rates among the Annex I countries, developed countries, are shown on this diagram. At this stage, no developing countries did not, no developing country shows a large amount of emission. And so the developed countries are almost responsible to the emission rate. USA 36.1%, Russian Federation 17.4%, Japan 8.5%, Germany 7.4%, etc. And so the developed countries are requested to make efforts to to decrease the emission. And under this UNFCCC's, the UNFCCC opened a meeting in Kyoto, which is COP3, called COP3 in Kyoto, 1997. And so they adopted Kyoto Protocol, which shows the necessity of reducing the uncertainty in the projection of climate change. This is the request towards the IPCC. And so also as for the target, quantified emission limitations and reduction in order to promote sustainable development. And the developed countries are requested to make efforts, especially greenhouse gases, to be reduced by Annex I countries as follows: carbon dioxide, methane, and so on, based upon 1990 level, and so on. And target rates, reduction rates are also determined. For example, Japan -6%, USA -7%, EU -8%, Canada -6%, etc. And also there are some related activities are determined. On the other hand, the IPCC message became more and more clear. And the 2007 fourth assessment report shows for the first time that warming with the climate system is unequivocal. So it's not any suggestion or possibility, but unequivocal, no deniable fact. So this is very strong message, unequivocal. the strongest message from IPCC. Then 2013 to 2014, fifth assessment report, fifth assessment report, AR5, again on working group one contributions, it was issued, and that it is extremely likely. Extremely likely is a little bit uncertain from unequivocal, but a very strong message anyway. Extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century. So this is the research progressed very fast, and finally, in the sixth assessment report, latest assessment report shows that finally it is unequivocal that human influence has warmed the atmosphere, ocean, and land. Widespread rapid changes in the atmosphere, ocean, cryosphere, and biosphere have occurred. So here again, as not only the observed fact, but also as the research fact of that again, strong message of unequivocal. The language unequivocal was used in this sixth assessment report. And however, after the long time goes on, and in 1991, as the same year when we saw the sixth assessment report, the same year, the annual global fossil carbon dioxide emissions are shown in this diagram. Now, China shows the largest, by far the largest emissions, and then USA and India, Russian Federation, Japan. So the structure is quite different from the earlier stage. So the international community discussing again, and also the under the Kyoto Protocol, the USA signed the protocol, but they did not next stage. So and then the USA resigned. USA then came out of the Kyoto Protocol, and so the international community, particularly at the UNFCCC meeting, discussions started very eagerly that we need more new framework, new agreement, and in the last stage, it was agreed upon that every country should show their efforts, what they can do, and we all countries should provide it their contributions or pledges concerning their efforts. And after the long discussions every year, agreement by all parties became ready to participate in mitigation. In the COP21, 21st session of UNFCCC meeting, conference of parties in Paris, climate change conference adopted a decision on Paris Agreement. It was in 2015. And then next year, the Paris Agreement was entered into force. And actually, this year, in 2016, entered into force. The Paris Agreement, some of the major elements are shown here, particularly in Article 2. This agreement aims to strengthen the global response to the threat of climate change, including by holding the increases in the global average temperature to well below 2 degrees above pre-industrial levels, and pursuing efforts to limit the temperature increase to 1.5 degrees above pre-industrial levels. This is very important article. And Article 4 also shows more clearly that, more precisely, that parties aim to reach global peaking of greenhouse gas emissions as soon as possible, and to undertake rapid reduction thereafter in accordance with best available science, as to achieve balance between anthropogenic emissions by sources and removals by sinks of greenhouse gases in the second half of this century. So this century, so the 20th century. So 20th century is 21st century. Yeah, that is something very yeah. The conference of parties serving as the meeting parties to the agreement shall consider common time frames to nationally determined contributions as its first session. Each party shall communicate a nationally determined contribution every 5 years. This is very important part. So they are all parties are requested to contribute their nationally determined contributions, namely 2020, after this one, namely 2020, 2025, and so on. At the time of Paris Agreement, 2015, various countries showed their major nationally determined contributions. as shown below. EU, for example, EU at least 40% compared to 1990 level by 2030. USA 26 to 28% compared to 2005 level by 2025, with maximum effort towards 28 and so on. They showed their contributions. However, they not necessarily unified or not necessarily. It's quite different. The basic level is different based on different years, and the target years is also various. So one research results shows, according to the national pledges and nationally determined contributions, the global greenhouse gas emissions should go on this way, and of course they goes up this way, and then this pledged and pledges and nationally determined contributions, if they abide by under the IPCC, under the Paris Agreement, then the greenhouse gas emissions will probably change in this way. And at the late 21st century, at the last year of the 21st century, their effort may shown by the temperature increase of 2.5 to 2.8 centigrade plus. So national pledges and nationally determined contributions only provide more than 2.5 up to 2.8. So this is quite different from the target of the Paris Agreement. So these pledges and nationally determined contributions are not enough for the goal of Paris Agreement. So, on the other hand, IPCC shows that it is unequivocal that human influence has warmed the atmosphere, ocean, and land. In AR6, and actually widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere have occurred. Now, the observation we have received a latest report of IPCC AR6 that the observed temperature changes from relative to 1850 to 19. These are the reference years. Average value of this period is assumed assumed approximately pre-industrial temperatures. So the IPCC considers this the relatively this years is as a pre-industrial level. Okay, so the from the pre-industrial level, the observed temperatures goes up around here, or that degrees, but since 1850 up to now, the temperature goes up, almost up this way, and I'll show the details of this red zones in the next slide. Here, this year, 1850 to 2024. This is a reference years, okay? So these are the zeros, almost zeros as an average. And then the observed reality shows this way, and this way, and this way, this way, this way. 1 degree above the pre-industrial is here. Okay, now it go above, and 2020 and latest one 23 and 24. Now WMO on 10th January this year, 2025, WMO showed the global average temperatures in 2024. The global average surface temperature was plus 1.55 degree above the pre-industrial average. Okay, above the pre-industrial years. According to the WMO's consolidated analysis of the 6 data sets, and WMO issued this analysis on 10th January this year. Latest temperature comes here, 24. For the first time exceeded 1.5 degree above the pre-industrial. Exceeded. Of course, there are yearly variations. So this is not a mean values, mean yearly values, but it is very astonishing that already the goals in the Paris Agreement is already here, is very dangerous situations. Okay, on the other hand, how the temperature change are different region to region. So regional distribution of global warming is shown here. This one is shown in AR's 5th assessment report, but this is almost the same today. And on continental areas is more warmer than the oceanic areas, and some part is cooling. However, as far as global scale is concerned, almost everywhere of the atmosphere, almost everywhere of the world are warming up already. Okay, and some of a very typically clear figure is shown on Arctic sea ice extent. it's it's quite far from your regions. You are quite near to the Antarctica, but Antarctica is a very big chunk of the island and big amount of ice sheet, and is rather stable. However, in the northern pole, the northern pole is covered by ocean with ice on center. So Arctic pole is covered almost every time on ice. That ice is called Arctic sea ice, and its extent is shown here. And recently, and there is a seasonal changes, and of course, in the northern pole, in summer of the northern pole, the Arctic extent became the smallest, and in September, particularly September, is the season that the sea ice extent is became minimum in a year. Okay, and particularly 2012 was very small, and latest one and 2024, last September, very small also. And if we pick up the average monthly Arctic sea ice extent of September, so September average monthly extent is shown in this diagram. It's now we are here, but we're here. Last year's value is here. Last September is here, but all the way this way, the value extent is getting smaller and smaller. This is quite clear. And then, as for the ocean, we need to concentrate on ocean, because ocean is a very important, has a very important activities, because ocean absorb the warming energy. So the warmed up the global warming is most absorbed, warmed energies absorbed in ocean. So the energy of warming energy, ocean warming dominates the increase in energy stored in the climate system, accounting for more than 90% of the energy accumulated between 1971 and 2010. So this, upper ocean contains energy like this, warming energy, and deep ocean here. The ocean is almost all the amount of warming energy is accumulating. And then the lowest, very, very small part, only a few percent, is the atmosphere. So the atmosphere is also absorbing the warming energy as you feel that the temperature is getting warmer year by year. So there is a year though there is a yearly variation, but very small purple part is shown here, very tiny part of atmospheric absorption. Now, on the other, let's see about sea level change. This is shown by AR5 already, and the red one is from the satellite data, and others are instrumental data, and then there is a variation, but globally sea level is getting higher and higher this way. And now the cause factors to cause recent sea level rise has been also calculated in AR5. It is very likely that the mean rate of global average sea level rise is 3.2 millimeter per year between 1993 to 2010, with high confidence. And this value is almost consistent with the sum of observed contributions from. So these are the causes of sea level rise. Ocean thermal expansion by the heat, okay? This is the largest cause of sea level rise. Next one, glaciers, melting glaciers, okay? And then comes melting of Greenland ice sheets, Greenland ice sheet. And then comes, it's more stable, but Antarctic ice sheet also melt. And the AR5 also shows new findings that land water storage also causes the sea level rise. And the sum of these contributions are summed up this way. Well, this is still quite a little bit smaller than 3.2 average value, but this is very main causes. And of course, there is some ambiguity or some need more better observation needed, but still these causes are quite definitely shows the cause of this sea level rise. Now comes the extreme weather and climate events. This is recently very clearer. Human-induced climate change is already affecting many weather and climate extremes in every region across the globe. Evidence of observed changes in extremes such as heat waves, heavy precipitation, droughts, and tropical cyclones, and in particular, their attribution to human influences. Has strengthened since AR5. Some recent hot extremes observed over the past decade would have been extremely unlikely to occur without human influence on climate system. So you, you may feel that there are increase of the number of the wildfire in the northern hemisphere, particularly in United States near California and Siberia areas and forest areas also. And in Japan, we also had a very, very hot summer last year. So what is driving the climate change? The natural drivers are existing from the old time, volcanic eruption, solar activities. But anthropogenic, man-made drivers are shown as follows: emission of greenhouse gases, emission of aerosols. Aerosols, most of the aerosols, particularly the smaller particles suspended in air. Aerosols, some aerosols act as a warming, and some aerosols act as cooling effect. And this is some very specific effects. So I don't go into the details, but there are cooling effect and warming effect. So aerosols is also playing a role of drivers. This is shown earlier. And then the IPCC 5 shows the changes of carbon dioxide in a long, long time, up to from 0 and to 1750 AD. And here, the same from 1750 to 2020, it's elongated. The year is elongated in this because to show the very strong. If we show the difference in the same diagram, then we will show in this way, and this way. But we elongated the horizontal axis. Okay, and so the growing rate is shown like this, very rapid increases. Okay, and as for the carbon dioxide, in 1750, this is the year as estimated as the pre-industrial stage also, and the 278 ppm, but recent one already 50% increase from the pre-industrial stage. Okay, 50% global concentration of carbon dioxide, and balance of sources of sinks of carbon dioxide. And the emissions coming from emissions of the emissions are the emissions from this the fossil fuel and land use. These two parts shows the and of course ocean absorbs this part. Ocean absorbs the carbon dioxide, and then the atmospheric growth, the emissions are absorb some other part, like the land sinks, and so on. And the rest of this part is growing part of the atmosphere, in the atmosphere. Okay. Now, annual global fossil carbon dioxide emissions are getting larger in this way. There is a COVID-19 pandemic, and then it is a global emissions are a little bit decreased, but then comes this way again. The latest value shows red one. Now, according to the countries, China shows the great increase of carbon dioxide emissions. USA growing, but then decreasing, and EU is decreasing also this way. And India is also going up, and maybe in this way. And some we don't know what will happen in the future, but so far China already came almost same with the EU total, 27 countries. Now, here is a very important diagram, okay? Originally, there are many climate modeling groups in the world. There are 60 models here. From Japan, 3 teams showed their results. 60 models. If we there are some model studies, and they tried to simulate the last century, or longest this long way, and now we stand around here. So these are we have all many data like volcanic activities and some other natural activities, and also all the global emission amount. So all these 60 models tried to show tried to simulate the past climate, okay, past climate, and then all the result shows all these way, and the result of average of these 60 models results show the red line, okay. This one up to around here, and black line is observed temperature change, okay. So simulation model result almost shows similar changes, and shows this way upgoing trend is quite the same. And so then they use the same model to project in the future, okay. And the future projection is shown again this way, okay, and here it's not shown. This one is only the last observed changes and the simulation, okay. However, this is another very important experiment. This one is the same as the last one, okay? Observed and simulated. It's okay. It's almost the same. So models are quite acceptable, okay? But the model can also simulate the way that we just take out the anthropogenic effect and put in only the solar and volcanic natural forces only. And then the model shows the similar temperature changes as the past. No increases, no warmings. This is the effect, the result of the difference. Whether the model includes the human activities or not. This shows the increase because the model showed included the human activities. And this model shows if we neglected the human activities. So that's why it is in AR6. The message came this way. It is unequivocal that human influence has warmed the atmosphere, ocean, and land. So there are in AR5, there are four scenarios are chosen, four scenarios, and the with other scenarios, but four scenarios are thick lines, okay, thick lines, four scenarios. And this is the emission from the fossil fuels, emissions, okay. And the black line shows the observed actual changes of emissions, okay. Almost the highest emission scenarios, actually up to unfortunately the actual value shows the almost along the highest scenarios. And the lowest one at the end of the century, there will be a plus 4 point pre-industrial, from plus 4.3 from pre-industrial, 2.8 from pre-industrial, and so on. Okay, this one, 1.6 scenario. So, as I said, this one, it's four scenarios. But this is the scenarios. There are zero emissions for the two scenarios on the way. Zero emission means we absorb all the emitted carbon dioxide and put it somewhere else, okay, in the ocean or in the ground. So the same thing that goes and then 1.5 plus 1.5 degree line here, and the very low scenario very low scenario or emission scenarios this way, the temperature increase above the pre-industrial level. Okay, so the lowest scenario shows a slight increase over the 1.5 degree, and then come back lower than 1.5 degree, and eventually 1.5 degree lower than pre-industrial. This is acceptable for Paris Agreement. Okay, and this second one is in the same way. There is a overshoot, but still it is lower than 2 degree. So these are the details of this very high scenarios, 4.4 degree increase, and very low increase, 1.4 and 1.8. So this one satisfies the 2 degree lower than 1.5 degree. This one satisfies lower than 2 degrees. Okay, and so the patterns are like this. The plus 4 degree warming, 2.2 degree or 1.2 degree, the different, quite different with changes. Okay, and also this one 1.2, 2.42 degree with the precipitation. And sea ice will go down, and there's Arctic sea ice, according to some scenarios, high level scenarios, the Arctic sea ice will disappear. Okay. This sea level change is also going up. Sea level is going up. There are some extreme cases, so, but I don't go into details. And also, this is another important aspect, that the cumulative total emissions of carbon dioxide and global mean surface temperatures are approximately linearly related. This is found out in AR5. This is the accumulated value of emission, okay, accumulated emissions. This is the temperature increase above the pre-industrial level. Above 1.5 plus 1.5 level is here. There are various scenarios. In any scenarios, if the cumulative carbon dioxide amount goes this way, and then in any cases, they are almost all along this way. So now 2019 value shows this here, this way. But 1.5 degree is here, and so we only acceptable this amount to keep within 1.5 degree global warming. This is called the budget for 1.5 degree target. So the Paris Agreement, according to the Paris Agreement, they asked the IPCC to further investigate the 1.5 degree target. And so the IPCC special report issued on global warming of 1.5 degree. Its complete title is long, from here to here. Here, from here, very long titles. But in modern pathways, no limited overshoot 1.5 degrees. Global anthropogenic carbon dioxide decline by about 45% relative to 2010 levels by 2030, and reaching net zero around 2050 to attain the 1.5 degree target. 2030, 2050 is a very important pie. Okay. And the recent reduction targets, they are defining 2030 and 2050. And by 2050, no emissions, okay, as shown by the graphs. And these are the developed countries, and some other countries, China, India, show their respective target. So this is a summary. The summary shows all the contents I talked today. Maybe I have few minutes over, but if you allow me a few minutes, I'll read them again. Okay. IPCC Working Plan AR6 was published in 1921 as a physical science assessment. Warming of the climate system is unequivocal. Evidence of observed changes in extremes such as heat waves, heat precipitation, droughts, and tropical cyclones, and in particular their attribution to human influence, has strengthened since AR5. According to the model experiments, it is unequivocal that human influence has warmed the atmosphere, ocean, and land. Under all scenarios of AR6, global warming will very likely exceed 1.5 degree within 20 years. However, under the very low scenarios, after temporarily overshooting 1.5 degrees, it will be coming down less than 1.5 degrees before the end of the century. Many changes in the climate system became larger in direct relation to increasing global warming. They include increase in the frequency and intensity of such extreme events as hot extremes, marine heat waves, heavy precipitation, and so on. Cumulative emissions of carbon dioxide largely determine global mean surface warming by the late 21st century and beyond. Budget for the 1.5 degree target is about 500 gigaton carbon dioxide at 2019. The existing NDC's nationally determined contributions under the Paris Agreement may not be enough. The only slight hope is existing in the Article 4 of the agreement, because the participants of the Paris Agreement need to issue their efforts, their contributions every 5 years. Okay, that's all I prepared. Thank you for your attention.
Thank you very much, Kondo Sensei. It was a very interesting presentation, and you shared with us a lot of data. Very, very, very interesting. We have a couple of questions.
Okay.
The first one is from Nason Freire. He is a student of this course, and he said, "Good morning, Dr. Kondo. I'm Dr. Nason Freire, a senior researcher at the Brazilian Institute of Geography and Statistics. Thank you very much for your very interesting presentation. I'd like to ask you, how satellite imagery can provide evidence of climate change in tropical coastal areas, such as the vast Brazilian region and other Latin American countries, for example. Are there any Japanese satellite images available that are useful for this type of research?
So far, Japanese satellite is covering the Pacific Ocean regions, and I'm not quite sure at this stage to what extent they can show the coastal regions data. I'm sorry, I'm not specialist in this region, so I have no data right now.
Okay,
But I
thank you
hope
very much.
someday all the areas of the world can be observed by satellite observation anyway.
Yeah, it's very important to have data, because data is the most important thing to have to be able to analyze this, right? We have a second question from Lita Peggy Verduga. She is also a student of the course, and she asks, could you explain why albedo varies due to climate change? The
Yes,
albedo.
yes, albedo varies. For example, the anthropogenic activities like forest cutting and the change, land use change, and all these human activities. And so human activity causes changes in the albedos.
Thank you very much. I don't know if somebody else of the audience have a question, but maybe I would ask one that maybe the students of the course will have this question, because you have shown us a lot of climate projection, right? A very detailed global climate projection. So if you could explain to the people here in simple terms, if possible, how these models are built and what type of information is used to feed them.
Oh, well, to start the model simulation, we need all the available data from satellite, from other remote sensing method, and also on the ground observed data. However, the observed data is not quite the same, and there are some very different positions and different density.
So maybe there's a challenge that we have that we can.
There are various challenges in this area. Yes.
Yeah, because as we mentioned before, the data is very important. So if we can
So
take
that's
that
why
in mind.
Yes.
Yeah.
Go on. Let me
We
say
have
additionally that that's why there exists international cooperation and activities on observation.
Yeah, cooperation, very important. We have another questions that are appearing. Good afternoon, says Karina Maribel Serna. She's also a student. Is there any program or application that it would be free so they will be able to analyze data in different countries?
Well, yeah, unfortunately I'm not in charge of these areas, but I would suggest that you can access for example, the JMA. They can probably provide some response and answers to your questions.
Yeah, I will complement. We are in this course, actually, we are going to teach our students how they can download some of the databases that actually they are free. And we are going to provide with some algorithms so they can analyze that data, because there's a lot of data, but it's maybe not so easy to analyze and to use it to achieve some projections for specific areas. So actually, it's something that we are going to do within this course.
Yeah, as for these questions, let me talk a little bit about my experience. I was involved in many international meetings of, and UNFCCC, and I was asked at one time the world organizations, and I invited at that time I was asked the detailed results of forecasted future over the Argentina and Argentina. Argentine specialists invited to the for some years to the Meteorological Research Institute in Tsukuba for several years, and they get that and analyze data, and so that was a very good example. And so that there could be some ways to develop such activities in the Chilean regions, because the Japanese modeling is a very high resolution models for future climate change, and so they can see the quite closely for example, the effect of the Andes mountains, and also and so that would be very interesting areas. Okay.
Yeah, no doubt. Thank you. We have another question from Gustavo Gomez. He asked, if we exceed 1.5 Celsius degrees, even if all the efforts of the countries are made, could the process be irreversible for humanity? Floods, rains, among others?
Well, it is as the conclusive way. I would, of course, there are some anthropogenic process towards the climate change, areas, but that's yeah, but well, that is still in a developing stage, and it is very carefully. It should be carefully proceeded because the one way could affect the another way of another event, and so the safe guards are always necessary. Yeah, but that's interesting areas anyway.
Yeah, no doubt of that. We have another question. We suddenly have a lot of questions. uh, One of the participants asked, how were the historical data constructed?
Mhm,
Yeah, I think he means the historical data, meaning the very
mhm,
long ago in time. Yeah.
mhm. Yeah. The data has been accumulated and internationally uh, uh, to some extent very much exchanged, and so particularly when we simulate the past century climate, we need all the possible all the available data in the past. So the cooperation by far quite satisfactory. And the as I as mentioned in this lecture, I first show the structure of the IPCC, and there is a IPCC shows as for the structure of the IPCC, the inventory task force is here, and this one is dealing with the data, global data, and so the as for the past climate simulation, we have very much relied on these activities.
And I think that some another way to create data or to respond to the question is that there's some studies of paleo climate. I think that's the correct term. So there's evidence of different in different ways to attain the data from the past to build these models. Yeah.
Well,
Yeah, we have another question from
okay.
Melanie Ramirez. She says, excellent presentation, Dr. Kondo. So she's very grateful for that. I have a
Thank you.
question. What recommendations do you have for local validation of climate projections in developing countries with limited historical data?
Well, when we try to investigate the high resolution model, high resolution results, high resolution analysis, we need high resolution data. But to some extent, we can manage to cover by some assumption of mean values, mean change values between observation points, and well, that kind of data management has been made in the past, and of course there is some limit, but there are some way to proceed that.
Actually, that kind of things we also are going to talk about that in the course. So thank you very much.
Yes.
And Melanie also asked a new question. How realistic do you consider the net zero emissions scenarios for 2050 to be compared to current trends?
To correct what?
To be compared to current trends. How
Whereas for the
realistic do you?
scenario is a economic and social scenarios is quite
The net zero, emission.
several emissions. As you have already noticed that the actually observed carbon dioxide emissions are quite near to the highest scenarios, quite different from the low scenarios. So it's very challenging.
Very challenging, yeah.
And also this is I personally think that the sociologist or economist made future scenarios, but they are a little bit optimistic along the way of the global environment. By the different way that people behaves more cleverly. But
Hopefully,
actually,
hopefully.
people behaves and to the other side of that.
So as you said, it's a optimistic goal. It's very challenging, and hopefully we'll move towards that. We have another question. He says, good afternoon. I'm Paul Luque from Peru. Thank you for your presentation. I was wondering if you are aware of any recent evidence on the relationship between climate change and the El Niño phenomenon, or if any models are being developed on this subject.
It's very, very good question. El Niño is a natural variation phenomena. And on the other hand, the climate change is so far man-made changes. Okay, and the natural variations are quite natural, and there is no way to change them. But the human-made anthropogenic changes are up to us to change it. So it's quite different. So El Nino will exist in any time in the future, and in any time in the past. It's depend on the structure of the earth and the structure of the various natural systems. Yeah, that's my.
Thank you very much. And the final question from Joana Maciel Guzman, and she says, what would be the minimum amount of data in years recommended for modeling and obtaining the most accurate future projection possible?
Well, it's depend on to what extent you need the resolution. So a level of resolution cannot be changed in the projection. We unfortunately we need to keep the resolutions as static in the projection. Yes, that's it correspond to the question or not, but I think so.
Yeah. No, thank you very much. I think I also think that. So that was the final question, and actually we're very much on time, so it's very accurate everything. So Dr.
I
Thank you
apologize
very much.
at the earlier stage of this lecture. Yeah, I was
No, no, no,
quite
no, no.
busy with
There's nothing to apologize. It was very interesting
it's a
and
very
a
good
lot of data.
experience. Yeah.
Yeah, no, it was everything very much okay. So thank you, Dr.
Thank
Kondo,
you very much for
for
your understanding.
yeah, and you can stop sharing your presentation. So we are getting to the end of the session. Again, thank you very much for your
Thank
time.
you
Thank you
for
very
your
much for your experience also. And I think this is very enlightening and very interesting. So uh, again, thank you very much. And
thank you
to
very much for
everybody,
that. Very
yeah.
nice chairmanship.
So with this, we reach to the end of the session. So again, thank you to everybody to coming. Thank you for the questions, for the interaction, and we'll be seeing each other in a future event. So thank you very much, and good night, and good day for you, Dr. Kondo.
You too. Okay.